Hello and welcome. I'm Bill Wake. We're here working on a program to compare tunes for similarity. I've been saying that for a while now, but we're to the point where we've computed a bunch of similarity measures, and we want to draw what they call dendograms that show us how similar things are. All right, so let me go to the Wikipedia page. Let's see. So here's a dendogram. Basically, these two are the most similar. They're the deepest nested, and they were the first match. And the height of their line is a representation of the distance between them. So you can see A, B are close to each other. They're all, those together, the cluster of those two is about the same distance to C and E. The height's similar. And the last one brings in D. So each of these nodes R, V, and U represents a set of matching nodes. Okay, so there'd be one for each thing brought in. Now, when we calculated similarity, we also, I'm trying to convince it, I don't want to update right now. Okay. We also calculated this L value, which is a measure, well, I don't know if L is for length, level, okay, but basically that's the distance metric that we're talking about down here. They switched in the article to calling it delta, I think. So, all right. So our goal is to, given these L values, calculate the dendogram. Okay. And I think, I'm not sure if this, let you know the node. Okay. I'm not sure how where we're gonna put this or exactly what goes on. Okay. But we know we're going to put it somewhere. And in our case, that's this cluster view. And we just created this object. It's by analogy to there's cluster view and cluster stage. This is what we do to make, well, in our case, it's a transform. So the transformation it makes is converted input packet to a new packet. We're just passing it through. So we're not doing any work. And then we have cluster view. And theoretically, we'd like to show that in the pipeline. Pipeline maintains the list of these, but it's given them from the application at startup. And I'm taking out this stuff when I can. We'll see if that still builds. Nope. Okay, let's undo that. Well, we can take out the comment. Okay, SwiftUI, yeah, there's definitely stuff we need, scene and window group and all that. All right, but here you can see the filters, the sources, the transforms, and the sinks. So these let you read in values, these let you modify it, and these show you things based on it, I guess you'd say. All right. And I think the other thing, oh yeah, the name, the icon name, and the stage type, really it would be better to put those in the cluster view, in the cluster stage. Okay, so a transform promises to be a stage, okay, and stage is promise I will have some input, stage promises I'll have a name, an icon name, and a stage type, okay? And I think it would be best if we manage that. I don't want to expose that, so I think I'll create a constructor for it. Let's find another stage. Manual input stage. I'm pretty sure we just declare some variables. Yeah, okay, we can init with it. Right. Okay. So let's move that stuff from cluster view. These three things they really should be part of our initializer. Okay, so let's do that. Public init. we'll take nothing and we'll call super with these things. Is it super? Am I remembering right? Okay, and then also this I think should be public. Override public. Okay, I can do that order just for consistency. Oh, I need to say super.init. Okay, and then I think this thing should be complaining now. Well, let's build. Yeah. Argument passed to call it takes no arguments. Okay. And, well, I think that should build, but I'm inclined to, let's put our transform in the pipeline. Okay, so sources, well, I'm going to break these out too. Okay, sources input, sources transforms and syncs. Okay, and if we add ClusterStage, okay, I think, well, let's give it a run. We're over on the UI thing more than we are anything else. Yeah, I wondered about that. So I don't really put in tests for this level of thing. It's really just kind of the starting config. You could probably convince me you need to. Let's see. I changed the cluster icon from the other day. I thought this one might be a little better fit. And interesting. That should have put it in. Quantize does. Let's see why that doesn't. Okay, so cluster stage. Cluster view. Oh, show details equals false. Is that right? Let's do true. Right now it's just going to be an empty thing. Yeah, well, not even that. Okay, let's see. Thanks. Yeah, I'm happy with that. It's allergens. Like, okay, whatever. It's funny to me. They have this tool to help you find the symbols, and just some stuff is just not really there. I mean, cluster seems like a good word to me, but nothing really came out of it. I don't know. I just find words sometimes that have no real analog, and so I end up, I don't know, looking for stuff and hoping. Okay. All right. So what's my problem here? Okay, my body is a V-stack with a Z-stack, which should have a sync shape. That's not right. It should be a transform shape. Let's see, who else is a transform? Filter. View. Well, let's do that. Although I don't think that's our problem. Okay, filter view. Show report. I mean, the filter view should show no matter what. So I'm not sure the colored view. Filter stage, show report. Okay, that's fine. That's controlling. I don't know what it's controlling. was referencing that. Some of these things evolved over time. Yeah, I wonder if that's needed. Okay, let's try again. No. Okay. I don't think I care about this. Stage I care about. Cluster view, where are you? Okay, stage. Yeah, filter stage. Init with filter stage. Did I not pass it in? I did not. I didn't do anything else to get it there either. What's going on there? These guys don't need it. Filter stage. Oh, there's somewhere that decodes all these things. Yeah, this is unfortunate. Okay. It's not, is it content view? I'm blanking out. Maybe it's selectors. This is it. Okay. I think I need something here then. So this didn't warn me. I mean, this is the only way I found to force, to allow me to have the stage. See, I want to go from the stage to which view it should show. And the stages all have one common parent type, stage, but then we have source stages and transform stages and sync stages. And we have to translate from the stage that's given here to which body should we show. Well, this needs an else clause. I think view not set up for I guess stage. I think we can say the name. I think stages have names, right? Add pound file. I think they changed this pound line. All right, so let's run it like that. Yeah, it sort of is a routing table. Unfortunately, oh, this is a view. I wonder if I can't print in a view. Let's just make a text with this content. Let's try that. I need some indication to remind me. All right, so hopefully this comes up with a text field. Yes, view not set up at stage view 28 for cluster. Okay, let's capture that. So we made cluster stage, initialize name, icon, etc. And then we added a warning to stage to view. Is that the name of it? Stage to view. Stage view. Okay. I think that's something. I don't think it's gonna. I mean, if a user gave me that, I guess I would know what it means, right? They're changing this pound file thing, but in this case, I'm not going to worry about it. I don't know. I don't know if I even have that update, but one of them, they've changed pound file to, I think it'll only go to the top of the project maybe, and it won't show you the context here. So people can't see, oh, this is on GitHub, whatever, they just would see the actual file name. And that's fine. I'll just put a colon here too. Okay. Maybe just line. All right. Yeah, I don't like it, but I think the first time you ever tested it, you would find out, and that's not going to be that's not going to happen without it. Users won't see this before I do. Yeah, I've got to at least let myself know that something's wrong. And this tells me what's wrong, and it also tells me where to go to fix it. So I'll take it. All right. And we can see the pattern here. I don't think we passed the stage yet, but we will. If the stage is cluster stage, we want the cluster view, and stage as cluster stage. I could certainly see, I think I tried at some point to put them in a table, but I can't really because these really do take different types, and so they just didn't seem compatible. It might be possible, but I think it's a compromise. Somebody might know a better way completely to do this, but I just could not find another way to make it so that I could have my generic stages and choose the proper view for them. Gosh, I would love to know a way around it. All right, let's run with this. We should get a cluster view with a colored brick and not much else. Yay. Okay. I guess our view needs to be doing some work then. Cluster view. Transform shape. Let's see what filter view does. Well, I think it does a controls view, yeah. Okay, we can do that. Let's make this a controls view. Stage is stage, and this is a well, no, it isn't. But text does not conform to view. Right. Oh, he's not really a closure in the same way as a normal one. Okay. I guess I can keep the V stack. But I need a print here. Okay. Something's still not right. Oh. Well, he's not exactly a closure. Oh, I've done something wrong. V stack. C stack, V stack, body. Okay. Okay, that's what we wanted to see. All right. Multi-line arguments should have their starting brackets. Yeah. I guess he's just complaining about how I'm formatting this. Vertical white space. All right. I think we're ready to start some work. Okay. All right. So connected ClusterStage and ClusterView with icon shown. All right. Now, I don't think it's really going to say select. Well, maybe it is. We are selecting. I'm assuming once we draw this thing that you can click on these nodes and that will select the corresponding elements. So selecting here on V would do A, B, C, E, and R would do all of them. Okay. Now, all right, I don't know. I guess I got to bounce around between. I've got an algorithm to write, and I've got to display it, and I don't know how much I want to. Like what does this thing look like, right? I guess the thought is, I mean, I think the clustering and dendogram is going to be relatively slow. I think it's at n cubed somewhere. So slow enough that we probably need a separate window for it. And you really do select within it. Somewhere this thing has to be given, well, the thing that really shows has to be given. It has to be given the information from the algorithm. Well, I guess let's find another one who shows like that. Let's see, Parsons Code melody average. Okay, so you want to view it, you have to actually bring it up. We don't have any input, but this is similar. Our filter is going to be similar. It's going to bring things up like that. So let's go look at melody average. Average tune, I think. The view. Okay, so we got controls view, right, and then sheet is presented based on show report. Okay, yeah. And the name of this is let's show dendogram. Okay, I made up that name. Let's make a view for it. Goes in both those. Yes. Okay. And it is a Swift UI view. Public class dendogram view is a view. Var body. I guess I don't need to do much else. Some view. All right, and text dendogram view. Okay. And where's manual? View cannot be satisfied by non-final class because it uses itself in a non-parameter, non-type, non-result type position. Public class, this is a view. Oh, struct. Wow. Okay. I don't know if I'm still. Dendogram view needs a stage. And it will need that stage. Okay. Private var stage of cluster stage. Okay. Okay, so this should present. Oh, interesting. Oh, that's because I have that thing set to false. This is the whole view. We got to give it some sort of close me button and stuff like that. But also I'm defaulting something false that needs, or true that needs to be false. That should only happen when you press the button. Okay, and let's see how the average tune view. Average tune view. Okay, he presents that. I think we'll need environment, right? What's he looking for? Average sync view. Yeah, we need this. The dismiss action ties in so it knows which window to close. And then, well, that's all its stuff. Give it a done button. Well, all this stuff is probably useful. Dendogram view. Button, dismiss action, border prominent. Well, I think this is all in a V stack. Okay, let's see how that does. Should pop up a window. Okay, we haven't worried about the contents. This should make it dismiss. And it toggles. Basically, the dismiss action knows what variable triggered the display and goes from that. The other thing I noticed here, this button is not the right color. Let's, I guess we could look at file input view. Button style, bordered prominent. It looks like all that's going on with that. Can put that outside. It'll inherit down to any level that needs it. All right, let's see how we're looking. Good. All right, displays. The fact that it's not filled in, I'm not going to worry about. It's not a big problem at this point. Mostly I'm just trying to get the mechanics hooked up, and I think we're there. Make dismiss button work. I guess we improved dendogram view. Make dismiss button work. Okay, that's probably close enough. All right. Now, given all this, if you want the dendogram view on a stage, well, ClusterStage has your information. You can ask it to transform. That's going to be a little interesting. So given the input packet, we that gives us the tunes. Let's see what's in the packet. Tunes and metadata. So metadata is about the processing of the pipeline. It's not metadata about a given tune. Each tune has its own metadata. But we get this list of tunes, and we can certainly take that and pass it into our clustering algorithm and get this stuff back, L and D. We don't even need D anymore. We've got L, and we've got a cluster. Now, let's, I kind of have to back up in my head a little bit, losing a lot of, I think we'll take out stuff to the right here. Okay. And if we look at cluster, okay. So with cluster, mini version of the dendogram, yeah. So you're thinking like take a copy of this one, this image. Quit with. Okay, well, I won't do his. Okay. Well, that might be a good experiment. Okay. Well, yeah. So my oh, I see what you're saying. In the pink box here, I think I may be wrong on this, but I feel like because it's such a slow algorithm, potentially, I got a feeling that it might be too slow to calculate that clustering and the dendogram and then display it in this. That's kind of the reason this melody average has a thing like that, is because it's a little slow. It's not super slow, but it's slow enough to be annoying, and it's big, so you kind of have it in your face. On the other hand, you probably wouldn't select it if you didn't want it, but I think I'll defer that. It would be cool if that could be done. I really wish I could cluster them like this, but that's probably a future project. I'm pretty sure there are algorithms out there that kind of fake that, or at least do a version of it. Yeah, so I think we had to figure out how to draw it, though, and I think that's where we are next. I think we have our cluster, and so if something is an outermost object, the leaves of the tree basically are elements, and then the interior nodes are clusters. And notice they have levels, 0 for the internal nodes, The leaves. Okay. And I think given a cluster, we've got the cluster, so it produces one cluster. I mean, the algorithm we did, it's not in here, is it? No. The algorithm we did produces the clusters. You basically give it the elements and it produces the clusters. There's one root cluster and each cluster has multiple children that are either clusters or elements. And we should be able to build up the dendogram based on that. Now, I don't know, given a cluster, can we draw? That's probably my next question. Where we get the cluster, we'll have to make that come through. But the clustering view, well, it would sure be nice if the dendogram view knew. Well, I guess it's going to. He's given the stage, so he knows the tunes and can draw the body. I guess when he opens, he has enough information. All right, so I'm going to say oh my, I may regret this. He somehow has to have a cluster, I think. And given a cluster, this text is going to turn into a canvas that draws stuff. And those lines are going to be the stuff it draws. I don't know how we'll get these bubbles in, but these names and the lines and the bubbles, maybe we can just do it without the bubbles first. Just get these lengths worked out. Okay, so if you gave me, or if I computed the cluster, kind of the root cluster of type cluster of element, okay, which means this thing has to be an element, which means other people will have to be specific. Element does not conform to hashable, okay. Element of hashable. Return from initializer, yeah. Now equals. Yeah. And I think I can probably just make them circles and give them a on touch kind of thing. All right. So I don't know what my type is here. What if I just do this? What will happen? I'm going to do this for now. Is it cannot assign because its type is not element? I'm going to make this internal for now. I don't know. I'm kind of halfway between a spike and a real code. I want to make it sort of like we did the other day with the integers and clustering them. I'm willing to make a cluster of integers first and then figure out how do I get my tunes into a cluster and then adjust the types and all that stuff. Okay. Cannot find element. Okay, so if we did cluster of int dot 1 0 27, I guess we'll be good geeks. Okay. I'm saying this thing should put, where are you complaining? Dendogram view stage. I think that's an old complaint. Okay. Dendogram view. So I'm building a cluster that's just one element. All right. Do I have enough information in the cluster to draw it directly? I don't know. Well, I haven't used Canvas very much, so here we go. I know Canvas lets you just do plain old drawing type stuff. Okay, so let's get a description. Swift Canvas. Okay, pass in context, pass in size. All right, let's draw something. Let's just take this example and see if we can get something working. All legs is dendogram equally spaced at level 0. I think the elements are all zeros. Let's see if we can get it. The elements themselves are zeros, but the first level thing that holds them, the actual clustering ones, are not. They can be, because this function is, I don't know, we didn't average it, but we talked about scaling it and stuff, but I think it's the sum, or it's some function of this element. So I think it could be 0 as well. So it would draw down there. I'm a little worried if C was also a 0, it would end up drawing this node the same. So we may have to put some other stuff in, but yeah, so these things are all zeros, but anything else is non-zero. They're all, I don't know, are they min? Let's see. I'd have to, are they equally spaced? I think so. They are this way. It definitely crossed my mind that the vertical spacing should maybe spread apart as much as the other, but the way they're drawing it, that's not the case. My understanding is this is all, they're all just spaced vertically based on the distance to put the names in, which will be a little bit of a mess for us too, but I think that's all that's going on there. Yeah. Okay, so this, hey, okay, it actually drew. It chopped off the edges because ellipses do that. Drawing to size does that. Okay. But that's a good sign. All right, let's see what you got to do to draw a line in there. Images outlined and filled paths. So what do? We called context.stroke. I don't know if it said what a context is. I guess it's a graphics context. Okay. Well, I can draw text, that's good. I can draw Swift UI views, that's helpful. Context that clip. Do I have to do everything as a path? It looks like it. Stroke path. Are they rectangles? Okay. How to draw lines. That sounds like me. You draw lines using path. Okay. Well, so, okay. Well, the problem I have is given this cluster, even if it's got all its lengths in it, is that enough to just draw it? I mean, it sounds like an algorithm to me. And like, oh, I forgot to turn this on again. Let's see. Won't help anything. But we can see what our to-do says we're doing. Connect ClusterStage to TUNE step. Okay, we've done that today. Okay, draw a dendogram. Yeah, that's where we are. All right. So I guess the struggle I'm having mentally is like the algorithm to draw a cluster, a dendogram, feels a little complicated, and this length I don't think is enough information to do it directly. If let's walk through their example again at some level. Okay, let's see. So okay, so here they are. They're doing the clustering part, which we've done. They find the lowest path distance. Okay, so D1AB over 2. What did we do up here? We did distance from RS. Okay, so we kind of took the minimum distance and said they're all that close. Okay. All right. So then they do this length estimation. A and B are connected. Okay, we set the distance, and then they're dividing by 2. We don't have to. I'm going to multiply by 10 because we got everything in a range 0 to 1. But I think for numbers, for starters, let's just take it what it is. I don't think we'll divide by 2. That'll be the length. Okay, so to draw, well, maybe I got to start at the simple case. The simplest case is we have one element, and so it should draw its name on the right, and there is no, I guess that if you could make the name clickable or something if you wanted to, but there's not much point in doing this if you're only going to bring in one item. You draw the name, and there's no cluster signals. So I'm treating a name by its, a one element thing is just the name A in this case. Oh, that's an interesting thought. Yeah, I was sort of assuming I would have to kind of recurse down to the leaves, and then on my way back up draw the pieces. Well, okay, let's take the simplest one. I mean, I think if, and I'm gonna say this is all spiky, and I don't know what we're gonna do. I think I'm gonna end up pulling the algorithm out. I think I need to create an intermediate structure that's like exactly the information we need to draw this stuff, but maybe it's there already. I don't know. All right, but if cluster how if let dot element, I guess cluster dot element let sequence number, I guess I don't need the word let here, sequence number, level, and name equal cluster. Then we're going to do something. Okay, so if our thing is an element, we're going to do something. Otherwise, I guess this is else if case let. I guess I should switch on these. Do something. And then case let cluster sequence number level name. Oh no, this is children. Do something else. Lose the if case let. Okay. Right. Okay, actually, I don't think I need sequence number in either case. And level, I'm going to need. Children, I will need. Level, I will need. Okay. Words in 0, size. Path. I'm curious about drawing text. Overlay it. I don't think I need to overlay it. Well, okay, here's the deal. The thing is I need to accumulate. I'm worried about the Y position, right? So I can't accumulate state here, I don't think, for it. Well, let's just write it and see what happens. So If it's that, it's text of name. That would be something. Okay. And where are we going to put it? Well, I think we have to... Well, let's do an offset, I guess. 50-50. I don't even know. All right, I'm just playing here. Okay, offset XY 50. Result of call is unused. Well, why is that unused? He's a canvas. He's saying text. Let's just try saying text. Hello? $100. Okay. Result of calls unused. It wasn't unused over here. Text. Offset. And it's not used here. Yeah, they're already sorted. The thing is, I'm not sure how you, like, you can't write a loop like that, right? Can you? I mean, it's not a fixed size thing, so I don't know. What? Well, I don't know what's going to happen here when I run this. Nothing's red, but it's not very happy either. Okay, so I got dendogram view. I don't have any text. Let's take out the ellipse. Let me see what's going on here. This overlay path, the overlay was put on top of the path, not in the path. I don't know. I don't see my text anywhere. So what if I put that over the path? Well, you know what? The sequence number does actually tell us that information. Like you say, it's a simple increment. I think sequence number, the way we set it up is those numbers correspond to the initial elements. So they come in 1, 2, 3 or 0, 1, 2 or something. It's not helping me get anything written here. Unused parameter. That's really weird. Okay. So they put a path in, they put the stuff, and then they overlay this on top. Okay. I'm going to steal this and then put my text in an overlay. Just try and get myself... path and dis, move, add arc, close up path stroke. I think it's in the canvas. I can't tell from here. Using path. That's a good question. Oh, they're not using. Well, let me go back up here. Oh, they are not using that in the canvas. Well, what is the canvas giving me? Kind of not so informative. A view that supports immediate mode drawing. Well, maybe I don't care about immediate mode. I'm not trying to dynamically draw, really. I need to draw it once, and it doesn't offer individual. Okay, maybe canvas just comes right out. Oh, already took it out. Oh no, here it is. Okay, what's the complaint? Path of value type. Okay, let me just take this much. I got to put a brace in there after. Dot fill. Path dot align should be a brace before dot fill. Okay, maybe that's more promising. I'm going to comment this out for a minute. Unused. Okay, yeah, I didn't think you needed this. Okay, something. All right, so I guess that's not. What's that text dendogram view? Okay, that's that. We overlay. Yeah. I really wonder if that coordinate system is not what I think it is. I mean, I think 0, 0 is the top left. Maybe I should be doing this little playground. I don't know. So 0, 0 is there. Let's go both ways. Move to point 2020. I mean, that looks like it's... Oh, I don't have a size. Okay. I mean, this seems like the coordinates starting in the top left corner, right? So move to 2020 is sort of like 0, 0 up in there in the corner. Add a line to x300, y20. Add a line to x300, y200 going down. Add a line for 20. Yeah, I don't know what he's going to be. Yeah, maybe he is centered. Yeah, I think you're right. He's totally centered by default, so that's why these offsets are relative to that. There's something else that's not offset, right? There's position or something. Well, there's a lot of choices. Position. Parent coordinate space. So let's try that. Common stuff for all stages. Okay, that's relative to this. Okay, so I guess the size. No, there's a way to put these in. Oh, what do you? There's something you wrap them in. No, I thought it was Control Option Click. Just common style for all stages. I don't know. They all share the main control view, I think, but I think I think this is okay. I mean, somehow, okay, I got to walk through something. Sides. I don't know. It's not frame. Yeah, Taylor Swift. Geometry reader. That's what I'm after. Yeah, that gives me that. Is that enough? See if I can get it halfway across the page. Well, it seems like a little less than that. But I know there's some border on this thing too. I mean, it's centered. Okay. Let's okay, so hopefully I can get this thing 3/4 of the way across the page. And Y is, well, I gotta get through these things. Because somehow I want to take the cluster, which is potentially multiple layers, and I want to kind of iterate over it. But I don't have the elements. Yeah, I can't get that unless I know it's an element. Okay. And this can do it. Let's see if that'll be allowed. Expected expression in list of expressions. Yeah, we would need to know, yeah, number of elements. I mean, we kind of know it at some point going in. Well, we haven't seen where the tunes are yet, but we do have a list of tunes somewhere. Yeah, so I think we can determine the drawn height is, is some number of text lines times that number of elements, and the lines have to take that into a, just have to accommodate it. They know where. I guess they need to know the number of the first and last, like the index of the list of items. That's really what makes me think we need to do a kind of a pre-processing, because like there's no collection I can iterate over here. I can't really iterate over cluster. I mean, I got to iterate recursively over its elements, and that doesn't seem like Swift UI is kind of really set up to do that. This part's fine to me, that we're making a line. I wonder if these, I don't know if the fill makes any sense. But apparently I can't put this switch statement in here. It's got to be an actual item. More's the pity. This is to teach me about that. I should put a space here. Oh, I did not get a line, in fact. Okay, that's worth knowing. Oh, 200. Let's just make it 24. Okay. Okay, I mean, I can place these, I can draw lines. That's not bad. So, I mean, if I'm going to draw, I guess what I need to know is like a list of lines to draw, or a list of things. I mean, they could be this, I could be drawing this kind of sideways U thing and a dot if I knew the positions of them. Okay. So if I had, it should not be hard to get a list of elements and their sequence numbers, and then I can just draw those boom, boom, boom down the side. I don't know if I'm going to worry about scrolling just yet. All right, so I just come in with those, draw those. Then I've got something else that says I'm going to draw. Well, I kind of want to say draw a U. The top branch goes to 0. The bottom branch goes to 0. They're different in the two branches. Okay, so the distance to the top branch is this, the distance to the bottom branch is that, and place the dot in the middle. And then I would have to know this distance would be 2, and this one's still 10.5. Okay, but if I had all those, knowing they're there, I guess it's a range. Is it always 2? Well, this shows it with 4 or 3, but I think given the algorithm above, we only will generate ones with 2. And actually our cluster says set, but it can really only be 2 elements. I think you need to know the distance to the top, the distance to the bottom. Then that gives you enough information to draw this. Is that always? Oh no, it does change vertically. So I need the distance to the top, the distance to the bottom, and then the distance vertically. All right, so 2 lists coming in. One is some information about the cluster thing. I feel like I'm thinking on my feet too hard here. Given those 2 collections, a list of nodes to draw and a list of angle brackety things specified somehow, maybe it's the range they cover. This one covers A through E, so it should be halfway between B and C, I guess, would be halfway for the dot. Okay. I think given those and given these, given this list, I can place them. All right. So I believe what we're going to have to do then is somewhere do some analysis that gives me a list of elements and their position in order, and then a list of line segment whatever things. 1.5 by height. Yeah, I think that's right. Is that right? Well, I mean, imagine if C and E were as close as A and B, and then this one we're trying to connect those 2. Can we set up a situation where that's not halfway? Well, it'll emerge for us, I think. I just don't have enough experience with these clusters to have a sense of what's possible. But I think given these 2 bits of information, I got somehow calculating this, right? Like these 3.5 and 2.0s, that stuff was being calculated along the way, and you need it kind of recursively to get to the next element. It makes me wonder if these things are like privileging, like say D and E were really close and A and B were really close and C was kind of hovering out in the middle. It would seem like you'd want to cluster A, B, and then D, E, and then attach A, B to C or C to D, E, and then do the whole thing. I don't know. I guess if it works, we'll see. All right, let's take a break. 3 or 4 minutes, and we'll come back and see if we can make our cluster give us better information for drawing purposes. Okay, so I will see you in a few minutes. All right, welcome back. Okay. So the elements in the cluster, I mean, if I had that, I could draw boom, 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 draw them on the right-hand side. So that seems like a good thing to know. Let's look at cluster. Now this, I mentioned earlier, like we don't put more than 2 in there. maybe it would be a good idea. I don't know. And I don't know that the value of keeping it as a set is really there. I don't know who uses this. Let's see. Okay, that's there. Test, priority matrix. Using that length. So are you suggesting instead of this kind of U-shaped thing, do a part of an oval kind of thing? All right. Oh, distance. Okay. I think oh, okay. The distance calculation is taking everything in cluster 1 versus everything in cluster 2, and it doesn't care that it's a set or a list. So let's try making this be a list of E and see what happens. We'll never have the same one twice, so I don't think it's going to hurt anything. Should be E. Okay, now this should not be happy. Reduce into, let's make this list of E. Item in so far dot. No exact matches in the pen. Let's see so far. Let's see his type. Error type, thank you. Array of E. Why doesn't he not like? Oh, contents of. What is values? I guess this is the same. I've got to put them in sets to make sure they're just the equal list of things. Right, same thing here. Okay, so what we did was we make cluster elements report a list instead of a set. Now, is cluster elements Okay, that does put things in order based on what they've seen. Okay, so I think, in fact, this elements is the list we're looking for. Okay, so if... Okay, so if I do for each... Oh, my elements are not... well, let's do cluster.elements id colon self. Okay, so now I'm going to write that, and so I'm going to do... Let's make this 85%. Y is... Oh, that's not going to work. I get burnt on this so many times. It's not the sequence number, it's really the position in this list. And I don't think I can get from there to there. Okay, I'll do enumerated. Oh man. Int can't conform to hashable. That seems unfortunate. Element. Draw it left to right. Well, I think the positioning of the names is going to be independent, well, kind of independent of the positioning of those U shapes. It doesn't have to be, but I just want draw it left to right. Yeah. I'm going to see if I can get this out first, I guess. It's still not clear to me how I'm going to get that. Int conforms to random access collection. Yeah. Well, I kind of have that information. Random access collection. Gosh, I don't know. I get into this with for each all the time. I just don't seem to fit the structure it wants. I mean, I can do a finite range, but I don't have a fixed range of these things. It depends how many things come in. Or you can give it a list, a sequence or collection or something. I guess it's got to be in a random access collection. Why a random access collection? Oh, because we do updates based on which ones change. Well, I'm also trying to do the easy one first, which you would think if it was so easy, I wouldn't be having these problems. Enumerated. Okay, enumerated sequence. And then the complaint is enumerated sequence event must conform to random access collection. I wonder if I'd find anything on that. Yeah, we're going to be... Well, I don't mind that part. Okay, I could zip. Is that really the best way? Yes, okay. For each required random access, enumeration is only in order. Convert the enumerations to an array. Okay, I can do that. Once it's working, we can improve it. Element this, and then y is 25 times item dot offset. Yeah, those will be the values eventually. I'm just using number right now. I think I passed in 42. Oh, darn it. Can I convert int? Sorry, I think I passed. I've passed 42 in or something for now. Okay. Just to get us going, I'm just doing int cluster. So this should only return one value and place it. All right. Moving too slow here. Okay, there's my 42. All right, so I'm convinced that would put something in the right place. Let's see what happens if I make a bigger cluster. So cluster dot cluster with 3, level 2, and then I think right now it's the list, element 1, 0, 42, element 2, 0, 24. Okay. And I expect these to come out in that order, 42, 24. Okay. I don't know, the positioning is going to be a little weird because I just made up the size and need to get it from somewhere else, but I gotta, okay, that's way too big. It probably it should be some sort of font size thing. 25. And I never can remember which comes first. That's not right. Oh, it is number and character. Okay, so the number is first. I think I can do that in here. Number element in. Oh, I haven't drawn any shapes at all yet, but let's see. So the values, I'm trying to get these. These are the leaves of our clusters. So anything that came out as dot element should be this list on the right, and then the U things are going to connect them. And I do think, well, the order may be a little derived from the cluster order is fine. Like they're out of order here alphabetically, but they're in an order that makes sense in terms of clustering. All right, so, well, let's put another one in just for, oh no, I don't want to get past 2. All right, let's run this with a different thing. Okay. Suspiciously far apart still. Just so I know what's going on here. Zero, 1. That y coordinate just doesn't seem right, does it? The text 10 times the number should only be 1. All right, we're going to do a comparison. So that's coming in just a little past this blank space. And if I raise it to 20, The first one comes in at 0. Position is 0 times float of number. Second one comes in at 1, should be 20. Now, 20 is not very far. Yeah, it should be the number of lines counted. So, but yeah, I don't think that's changing position. So so cluster.element should return only the leaves 1 and 2. That's their sequence number, just text lines. We're not doing any, I'm just drawing that green line still just because I have how to do it. But this is just, it's just trying to draw the A, B, C, D, E thing. Only it's 24, 42, 42, and 24. So when you say dot elements, it should fetch out element 1, 0, 42. No, it should fetch out 42 and 24. And then the number enumerated, says count them. So this is 0, item 0 is 1, item 1 is, item 0 is 42, item 1 is 24. That should come in here and draw this text positioned at, the width is 85% of the way across the screen. The height, I would have thought, something is funny. Number, I would have thought this should draw it at position 20 or 10 or whatever. Let's do 0 and see if they draw in the same place. If they don't, then something's really going on. They do what they want to do. Huh. See, this leaves me very confused. The text element should be placed, and the 85% looks right to me. I mean, it's more than 3/4. Yeah, it should really be text line height, but like I changed this to double its size and it's not affecting it. Let's make it 50 instead of 20 or 10. Yeah. Oh, it is moving down. Why? That's so weird. It definitely is further down because it was up here by the gap there before. 50 moves down that much. 0 didn't. That 0 puzzles me. Okay. If I do y of 0 times something, it should be positioning at the same y coordinate every time. And yet it's not. I mean, it's closer to the gap here again, but that's not right. Okay, let me add another one. Dot element 4036. Okay. Number is the counter position. So this turns elements as an array of integers. It's going to be 42, 24, 36. Let's make it 99 just to be very different. Okay, 99. And then when you do enumerated, it turns it into a pair 0, 42, 124, 299. Okay, now I'm going to take this out. Like this, I guess. Okay, so everybody says they're going to position at y equals 0. and theoretically running through a list of 3 things, all positioning. This shouldn't change in the loop, and this shouldn't change. So they theoretically should all be overriding each other. Now maybe I need to do overlays. Maybe it's, I don't know if it's doing its own thing. Okay, something is really weird. 40, it should be in this order, 42, 24, 99. But it's not coming out in that order. So I'm glad they're coming out on different lines, I guess at some level, but that's not me doing it positioning wise. So there's something odd here. I don't know what I can overlay. I mean, overlay like this puts it on another element. Overlay alignment content. Okay, default alignment is center. Well, we can put, yeah, see, that's putting it on the other view. Okay, let me put this in a Z stack. Sorry, can you log that value? Okay, I think that's progress. Slight as it may be. Okay, let's put this back as position. I'll say 5 times that. All right, so that should change them vertically. Whether they're close or far apart, I don't know. Now, like I said, also their values concern me. Okay, that's more like what I would expect. Okay, 24 at 0, that does not sound right. But, all right, let's make this 20 and move on to the next problem. I'm a little tired of clicking this too, by the way. Okay, that is what I kind of expect. Now, the order 42, 24, 99, that is the order I expected. Okay, what else is going on? Let's run it again. I mean, that should not vary in order. It's a list. Okay, there it is. It's varied. Okay. I'm going to take this as a modest sort of win. Make the dendogram view display the leaf elements on right hand side of screen. Okay, now this bugs me. So I'm going to take this as a test case. Uncluster. Let's. Okay, if I ask a cluster for its oh, this was supposed to be a list now. That's why it's coming out random order, because it's a set. Okay, let's make it a list. See what breaks compile wise. Nothing. We'll run test then. Okay, so let's make cluster hold a sequence of children rather than a set. Okay, and then that means I don't think we're going to see that problem now. I'll make a test for it, but 42, 24, 99. Same thing in here. I don't know if that would change, so we'll run it again. Okay, and one more just for charm. Good. All right, now I promised to make that a test. Let's find cluster tests. Cluster.elements should be 42, 24, 99. Okay, and that should pass. And I don't know if it knows its elements. Yeah, let's move that up with that. All right. So back to this thing. Well, now I think we're to. I'm caught up to what Mudshark 666 suggested earlier. Let's get these U things going, and I think again, what I'm going to do is, well, I want to create some sort of element that tells me what to draw. Okay. Take this out because I don't think it's the direction we're going at this point. Okay. So what I want to do, well, what's the thing to draw look like? Let's make come back here again for the 8 millionth time. I need to know, how long should this bar be? Okay. In this case, it's only 2, and in this case, it's 8.5. Okay. And the lower bar, so I need the upper bar length, the lower bar length. To Mudshark's suggestion, can only be a 1.5 difference. I don't know. So I'm thinking of a case where C and E were very similar to each other and grouped together. And then this line for R, I'm sorry, CE grouped together, AB grouped together, I would expect one that connects them above, and then the line for R should be in the middle of that, which would be between B and C. So I don't think it's going to be a 1.5 lines every time. But I think you're giving the most, the closest clusters are always nearer the top, I think. I don't know if that will help us. I guess the start of the bottom line is always the next item down in the list. So like adding D, its bottom line has got to be equal to that. But its top line, is its top line is the average of them. All right. Top line length, bottom line length, and then a height, I guess. I maybe need a node name or something there eventually, but I think those three will get us drawing something. We can at least draw this piece. The height, I think it might be given we're always adding a pair, is it always the average of the ones so far? I don't know. All right, we'll find out. So let's just define a little struct here. Private struct. Line, I don't know what these are. The connection. Is that what that is? Or it's a how about a cluster? Cluster, top line is the middle of the lesser cluster. Yeah. And is that always going to be like 0 through n minus 1? If we're on the bottom line is n, is it always going to connect to 0 to n minus 1? Or, I don't know. All right, I'm just going to say connection for now. Connector. Okay. And it's got a top line length is whatever cluster has. Double of double. Bottom line length is double. And height is double. Whether we need it or not. I think the way we're forming this, because it's always the nearest neighbors form a cluster, and the next cluster is what's the next nearest neighbor after that, and the next one after that. I think because of that, you're always adding a bottom line to a group containing all the previous ones, because you wouldn't have put this one next if all these weren't clustered together and you were about to join to it. So this order is affecting that. So I think the height is, is kind of these minus 1 divided by 2 or something like that, is my approximation. So I think this field may be not really necessary. Okay, but who's going to fill this in? I guess it's a question to me of, is it a cluster's job to know these connectors, or is this really coming out of the drawing process? So it's just kind of a question of how to best connect this to the program. Like, what's the dependencies I want? I can do it in here for now, but it's something we really should consider. So, whoops. Sorry, to do is what I'm after. So draw the dendogram. Well, we draw the leaf nodes in the dendogram. Okay, and now we got to draw the cluster nodes. Okay, this we did, more or less. Okay. I guess along the way we also make cluster hold a list of children rather than a set. That's kind of a noticeable change. Okay, so given this stuff, given a cluster, All right. And I think also the height of this is always the height, the L value in the cluster is the height of this bottom node always. These two together isn't not the algorithm we're using. So, all right. So I'm just going to define a little function here, but it's a pure function. Maybe, wait a minute. Maybe it does belong in cluster. Let's make this public, and I think we can. I think it's something we should do. So where's cluster test? Okay, so I think test cluster. I don't really like can in tests names. All right. This is a start. Oh no, that's not actually the way things are going to be though. All right. Leaf elements, always 0. Okay. Right. So if you ask for C3 dot connections, and then we're going to assert that's equal to what? Well, it doesn't need to do anything for the elements. I mean, oops, I'm not looking at the right thing. I think top line length and bottom line length are going to be equal, and height is, I don't know, do we need height? Okay. In this one, what I expect to get out is actual should be a connection with top, what's it called? Well, let me make it 0.75, 0.75, and I don't know. Well, I think it should be a half. It's going to be halfway. The dot is going to be halfway between 1 and 2. So this is 0, this is 1, halfway is a half. I guess. Cannot find connection in scope. Connector. Okay, and then connections doesn't exist. Connections, public func connections returns an array of connector. Okay. And so this should be, well, let's do this. actual dot count should be 1. And actual sub 0 should be that connector. Okay. Let's just return an empty list. Okay, we should get a failing test. That's usually not a problem. Connector must conform to equatable. Okay. Oh, I thought I was, yeah. I think I could change those names. Just top, bottom, and height. Maybe top line. Build failed. Rename failed, more like. Okay. Index out of range. Actual count is not 1. Okay. Cool. So there is nothing in there, so let's put something in there. Now, I think what we've actually got a singular case. The first one is the only one where the bar lines are the same height. I think. If I'm connecting two elements, it should be the same height. Okay, so all right. So I think I'm paying for this, man. I don't want to. I guess I'm trying to ask if the elements in that array are both, if they're both dot elements, then we make them equal. Okay, I'm going to back up a little. I think that's a perfectly fine first test. Maybe not the best in the world, but I think it's okay. I'm going to take this out. Well, I'm going to leave this for a moment. Well, I'll take it out. We're not using it. I don't want to confusing things. All right. What I want to do instead, let's make sure test pass again. I'm going to change this yet again. I'm going to make it 2 clusters, and that's going to be it. Okay, so cluster. So we're going into a refactoring. All right, now people should be complaining. Yeah, recursive enum is not marked indirect. Fix. Okay. Tuple pattern has the wrong length. Right. So this should be let cluster 1, let cluster 2. Okay. And then my elements to return is just can I add? Okay, cluster 1, elements, append. Okay, so before I was calling these things recursively, calling each item's element. So I'm doing the same thing, cluster 1 elements. Oh, he's not. Oh, dear. Okay, I don't think this is needed anymore. The problem is I'm not modifiable, maybe. Okay. Okay, so take cluster 1's, no, elements. Okay, I gotta break it into stages, I guess. I don't need this little array because it'll copy it by default. Okay, get the cluster 1 elements, append the cluster 2 elements, return the result. Okay, I'm guessing there are other places that are not happy. Anybody who sure. Anybody who used that array from before is going to be complaining. Okay, I don't know what those complaints are. Did I leave out a... I guess I got an extra one. Okay, that's the end of the switch. That's the end of the method. Okay. Now we have two things. We're just looking at the level though, so that doesn't matter. And sequence number. Okay, that should be this. Okay. I still should have complaints. Okay. This is now no longer legal because we only have 2 children. All right, so I'm just going to take off that 3rd child. Okay, so cluster 2 with 2 children. All right. Okay, this problem we had can't happen anymore. And we still get the elements as an array of elements, but cluster formation is no longer the same. That was the only place in our cluster method that might have done more than 2. Let's see, I'm going to go about 5 more minutes here, get this thing, finish refactoring this, and we'll pick up tomorrow with the testing. So tomorrow is Tuesday. It's 2 to 4:30 p.m. Eastern Time, or 6 to 8:30 p.m. UTC, as usual. Okay, should be some tests. Yeah, what we got there? Cluster. Okay, this is going to be a little interesting. Okay. Let's let clusters equal the array cluster 1, cluster 2. Now we can run through both of them together. Right. Okay, that's sorting. It's funny. Yeah, I don't know if it says necessary now, but okay, let's see how we do. Okay, Bill's happy, that's good. All right, so refactor cluster to contain 2 clusters rather than an array of clusters. Okay. And I'm glad it was only 3 or 4 files that got touched there. All right, we'll pick up, let's make this test fail. And we'll leave it there. Okay, I may take this back out. Let's make sure these pass. Okay, so what's the difference? Okay, oh, I don't feel bad then. All right, that was just the test. Our only thing not passing, we have a red test, so I think I can leave it there. I won't bother checking in. I don't want to check in junk. All right, and it fails the same way in the same place, which it should. All right, thanks again for joining, and I hope to see you tomorrow or some other time. Take care. Bye-bye.